Have you ever just stared at an algebra problem and it just looks messy? Variables and numbers are all over the place. Well, today we are going to tame that chaos. Let's dive in and see how we can turn those complicated looking equations into something way more simple and totally solvable.
I want you to think about it like this. Solving an equation is pretty much like tidying up a messy room, right? You wouldn't just pick up one thing at a time randomly. The smart move is to group all the similar things together first. You put all the socks in one pile, all the shirts in another. We're going to apply that exact same logic to algebra. Simplify first, then solve.
Okay, so before we can start our big cleanup, we need to understand the single most important rule of the room. And that rule is all about the equal sign. Seriously, think of it like a wall that divides your whole equation into two separate sides. You got a left side and you got a right side. This slide breaks down that wall rule perfectly. So if your like terms, your socks, are on the same side of that equal sign, you just combine them. You add or subtract. Easy. But if they're on opposite sides of the wall, you have to move them using a different set of rules. For today, we are focusing completely on that first part, what to do when they're already on the same side. So with that rule in our back pocket, we can come up with a super simple, repeatable plan to tidy up any equation like it's thrown at us. Let's take a look at our three-step strategy. And here it is, our three-step game plan. First, you identify the like terms. Find all the terms with the same variable and all the plain old numbers that are on the same side of the wall. Second, you combine them by adding or subtracting. And this is absolutely crucial. You have to keep the sign with the number right in front of it. And third, you solve. Because after you combine everything, you're going to be left with a nice, clean, simple two-step equation that's so much easier to handle. Identify, combine, solve. That's our mantra today. All right, enough theory. You know the best way to learn this stuff is just by doing it. So let's put our three-step plan into practice and clean up a few equations together. Okay, here's our first problem. We've got 3x plus 4x plus 2 equals 23. You can see right away there's a little bit of a mess going on the left side of our wall. So let's apply the plan. Step 1, identify. The like terms on the same side are, you guessed it, 3x and 4x. Step 2, combine. Since they're on the same side, we just add them together. 3x's plus 4x's gives us 7x's. It really is that simple. And just like that, the power of our plan is crystal clear. We're left with 7x plus 2 equals 23, which is a super simple two-step equation. From here, we just subtract 2 from both sides to get 7x equals 21. Then we divide by 7, and we have our clean and simple answer, x equals 3. See? Not so bad. Let's try another one. This time, we've got 5y minus 8 plus 3 equals 25. So what are the like terms on the left side this time? It's not the variables, right? It's the constant numbers. Exactly. We identify our constants, -8 and +3. And notice I said -8. You have to remember to keep the sign with the number. So we combine -8 and +3, which gives us -5. Our messy equation is now the much friendlier 5y minus 5 equals 25. And from here, it's a piece of cake. We add 5 to both sides, we get 5y equals 30, divide by 5, and we find out that y equals 6. See? The process just works, every time. Okay, let's ramp up the difficulty just a tiny bit. What if the whole mess is on the right side of the equation? Look at this one. 12 equals 4k minus 9 minus 7k. Okay, don't panic. The plan is exactly the same. We just look at the right side of the wall this time, and we identify our like terms. We've got a 4k and a -7k. Step 2 is to combine them. So 4k's minus 7k's gives us -3k's. It doesn't matter what side of the equation they're on, the rules don't change. And boom, just like that, our tricky problem simplifies right down to 12 equals -3k minus 9. We solve it by adding 9 to both sides, which gives us 21 equals -3k. Then we just divide by -3, and we get our final answer, k equals -7. The system works no matter how messy it looks at first. Now that we know the right way to clean things up, it is just as important to know what not to do. Let's look at the most common mistakes people make so you can just sidestep them completely. So there are two major pitfalls here. The first, and honestly the biggest, is using the wrong tool for the job, using opposite operations for terms that are on the same side. The other is trying to combine, apples and oranges. You just can't add 3x and 5 to get 8x because one has a variable and the other one doesn't. Let's really zoom in on that first mistake because it's a huge deal. If you see 3x plus 2x equals 20, both of those terms are on the same side of the wall. Your instinct, your gut, should be to just combine them. 3x plus 2x is 5x. The incorrect move is to start thinking you need to do the opposite and subtract 2x. You only do that when you're moving things across the wall. If they're in the same room, just put them in the same pile. So we can clean up equations. That's a great skill for math class. But you might be sitting there wondering, okay, but when am I ever actually going to use this? Well, this whole idea of simplifying things first is way more common than you think. Think about something like managing inventory. Let's say a store has X shirts. They get a new shipment with 2X more shirts, and then they sell 5. So the total they have is X plus 2X minus 5. Now that's a little messy to calculate every single time. But by combining the like terms, you instantly get the simple formula 3X minus 5. This makes tracking your stock so much faster and way less likely you'll make a mistake. It's all about being efficient. So, today, you've really mastered a fundamental skill. You've learned how to take a messy, confusing problem and simplify it into something you can actually manage. You've learned how to organize the small messes. So the only question left is, what bigger, more complex problems are you ready to solve now?